Okay, so this is attempt number maybe 20,000, but we're going to try and move quickly through this because I realized I was probably yapping a little bit. So in this video, we are going to be doing a few things, namely working on data imports and then doing a lot of work on wrangling, cleaning, manipulating, whatever you want to call it, our data sets. We're mainly going to be using tidier um, package functions. You're going to see a lot of new functions that you may have not seen before, and then we're going to be using operators in ways that you maybe haven't seen before, such as pipeline operators and OR operators, and then a few functions that you probably have used, but maybe in ways that you haven't. Uh, Generally, the plan here is to pull in this data set of New York housing prices. So essentially what we have is a big data set that contains information on a bunch of different properties. And that includes the city and the price of the actual house. And it's not just houses, it's condos, apartments, and others, but I want just houses. In fact, you can see what I want to do here on this document. So first we're going to import it using the reader function read CSV. And then after that, we're going to view it. After that, we're going to create a new column or set of columns that actually splits up one of the columns that's on this data frame into city, state, and zip code, because what we want to do is just pull the city. A lot of tidier, a lot of probably mutate and like STR stuff, but we'll get into that. After that, we're going to pull only the rows that contain buzzwords like house and homes. Going to be using STR or string detect, fixed string detection. And we'll get into that. We're doing all of this sequentially as well because when you see it on the Markdown file, that's kind of how it happens as well. And I think it tells a good story of how you're kind of manipulating this data set for reproducibility reasons. So then we're going to be calculating the average price for each city that is reflected in that large data set. Then after that, we're going to identify the 5 cities with the highest averages. Say, okay, well, I want to make a bar plot, with just 5 because, having a list of 100, I can't make a bar plot with that, or at least a viewable one. So we're just going to identify the top 5. And, I'll give you a hint, Manhattan is one of them. So after that, we're going to create a data frame from which we can make a plot. And this data frame is essentially going to have 2 columns. It's going to have a city column and an average price column. And it's only going to have 5 rows. It's going to be the 5 cities, that have the highest averages. After that, we're going to make a bar graph that kind of tells us a little bit about what's going on. So let's get right into it. And I am using a cheat sheet, and I'm going to be just like funneling all the code in. So definitely do not think that I'm just writing this off the top of my head. I'll need a little bit of help sometimes. So, all right. So what we're going to do is actually clear out this whole darn thing. And then I'm going to insert a chunk and I'll explain it kind of briefly, but essentially what we're going to add here is we're calling to the knitter function. And what you can do with the knitter function is use the root dir function. Or I'm sorry, yes, you can use the root dir argument in the set function. And essentially what you're doing is you're saying, I want this entire markdown file. I want to use this as my main working directory. So you don't have to worry about setting a working directory after this, which is nice. So, and then after that is just the standard default knitter function that you'll find, which essentially just allows global options on individual code chunks. And I will explain that on a later date. So first, let's import all of the libraries or call to all of the libraries that we're going to be using. And we're also going to be using ggplot2, obviously. So we're going to add this in as well. You'll see why we use all of these, in later chunks, and I will explain it. But I like doing, the working directory stuff and the library stuff up top, and that is a standard across all coding, especially in RStudio. So definitely try and get in the habit of doing that. So now what we're going to do is we are going to read the CSV file in. So it's called this in my working directory, which is essentially just this folder right here. You'll see that I have the file. It should be available to you. Let me know if you have any problems with that. Since we already specified the working directory that we're using, we won't have to use the whole path. So it kind of makes this very clean. And the top row is indeed the name of the column, so we don't need to do the header argument or do anything like that. It's just the function. So let's run these code chunks, make sure everything's cool. That's fine. And then let's run this function. So there we go. And we're going to use the glimpse function as the way of kind of viewing what we're looking at here, because I think it's very readable. But these are actually the names of the columns. So columns are rows on here. We'll see there's 17 columns. There's only maybe 3 or 4 that we're really going to be looking at, and that includes type, price, state, and that is actually all we're going to be specifically worried about. And then I'm going to show you guys how to rename, yeah, before I show you guys how to rename a column, I'm going to show you how to check to see how many missing values you might have in each column. I just want to show you guys just in case you want to use this in the future. Boom, we have none. There's very easy ways to deal with missing values that we can cover in a different video. Next up, we're going to rename the state column to city underscore state underscore zip. And that's only because in this data set, you'll actually see that when it says state, it actually has the city, state, and zip code. And it's actually a standardized format. So it goes city column space, state space, zip code. That's important for some of the functions that we're going to be using later on. So let's do that whole darn thing. And now we are getting into the cleaning. So first things first, we are going to separate the city, state, and zip. And it's actually going to be a 2-step process. So I want to show you the first step and why we're doing it. But I'm probably also going to have to show you the second step first. And kind of just explain to you the major differences here. So the reason we have to do a 2-step process, and I'm sure that there's a way that you could parlay these two, but that's just the way that I'm doing it. I encourage you to find a different way of doing it. But the reason we're doing that is because the separation of the variables of interest are different. So there's a column space, and then there's just a space between city state and state zip respectively. So I'm going to have to use, a different specification or use a different, you know, use a different value in the sep argument in order to specify that yes, indeed, city and state zip are separated by a column and a space, be very specific. And so that's what we're doing with this function. Now, after you do that, it's important to view, your data frame and see if it indeed worked, and it did indeed work. So you can see we have just city now and state zip. We actually we don't need to separate state zip, but we're going to do it just because I want to show you guys that, you can do this for different types of separations. And by separation, I just mean the way in which data is separated within, a box. So a comma separated value, means that things are separated by just a comma. Um, and we're using the separate function, by the way. That's kind of like the main, actually, crux of this entire thing that I should have explained at the start. We're using pipeline operator to say, hey, we're about to use this function. And it's going to be a long one, so that's sometimes why you use the pipeline operator. And I'm assigning the same name to it just because I feel as though we're not making any significant changes to the data set. So after we do these things, very similarly, instead of the comma space, it's just a space, you're telling the computer, hey, this is how they're separated and this is how you should expect it to be merged. And boom, there we have it. And that is just one of the many steps we're going to be doing in this chunk. So next up, we're going to check our work using the head function and also by using a pipeline operator or select, or similar to filter. but it's just a good way to check without having to move between environments. Hey, is this working? Um, so after that, we are going to be using the filter function. And now what we're going to do is when you look at this data set, you'll see that there's actually many different types of homes, and it's in the type column. So you can have a condo, you can have, a co-op, you can have um, a lot of different things. But I want just homes or houses because I feel as though that is the most, that is the category in which you're going to see the least amount of variability. And I also want to see the highest price. So I just want to choose a specific one because I feel as though having so many different types of housing will actually affect the average prices that we're assessing. And it may not give me a good reflection, of what an average house price might actually be. So that's why we're going to be hyper specific about the columns that we pull. To do that, we're going to be using the filtered function, and within the filtered function, we're going to be using the string detect function. And then within that, we are going to be specifying that it is indeed a fixed string, meaning this string of words, home for sale, can happen at any point in the box. So meaning it'll pick up on town, or sorry, let's say you have a house for sale, which is, these are just kind of parlayed together. So that's why there's two of them. Um, you'll notice that there's a column, or in that column type, you'll have townhouse for sale. So now what I'm saying is pick up the house for sale off of townhouse for sale. You can be hyper specific. That's why it's a fixed string. Same goes for home for sale. So multifamily home for sale. I'm just saying, hey, if it says home for sale in it, pull it. If it says house for sale in it, pull it. Because at this point now I know that I'm just getting houses or homes or the type of property that I am trying to measure. Um, if there was a mansions one, I would also specify mansions, but you get the point. So after that, you're going to be finding the averages of all of these prices, because what you'll notice in this data set right now is we have essentially just all of the prices for all the individual houses. And so in order to create a new column or a new data frame that contains a column with the averages in it, we're going to be using this. Um, and within this whole function, we're going to be using the group by function. So pipeline operators, we're going to be using the summarize function. The summarize function is good for finding like mean, median, mode, other things, that are within your data set. And it's usually found after using the group by function, which is essentially saying, hey, I'd like to specify that we are working within this column in this data set that we just made over here. And then I would like you to summarize or essentially tell me the average of this column within this data set as well. And I want it to be grouped by city. It'll make sense when I show it to you, but essentially this right here is telling the function, hey, after you group together these rows by city, please ungroup them. You never know if your data set needs to be in a certain order, so this is just a good habit in case that is the case. So after we do that, let's check it out. Oh, look at that. So now what we have here is essentially we have the group by, they're grouped by city, and this is the average, of all these cities. So we have 62 cities. We're not going to make a bar plot with 62 cities. We're just going to find the top 5. The top 10 would also work, but as you can see, it is not ordered. So that's what we're going to do next. And by ordering it and cutting it down to only 5, this is actually going to be 2 separate steps. So what we're doing in this step essentially is we are pulling the cities with the 5 highest price averages. We're not actually creating a new data frame with this. What we're doing is we're actually, I believe, creating a vector. And so, what this is going to do is say essentially, okay, I'd like you to arrange this in descending order of average price out of those 62 cities. After that, and meaning, the highest is going to be at the top. So after that, I'd like you to slice the top 5, and pull all of the data from which the city has. essentially, give me the 5 top cities after putting this list in order. Um, and there won't be too easy of a way to see it unless you could see it already over here. So let's use the print function. So essentially what we just figured out is, hey, these are the top 5. So a function that you guys are very familiar with, and I know because you guys were showing me in DataCamp, is the filter function. So that's exactly what we're going to be using next. We're just going to be making a new data frame that filters out all of the um, top 5 cities. And again, we assigned this variable my housing top or NY housing top 5 um, to suggest that these are indeed the top 5 cities in this big list or in this big data frame. So um, yeah, so we're filtering within the city, variable, the top 5 average prices of houses. And now you can see why this all has to happen sort of sequentially, especially if you're doing it a specific way. And I'm very interested to see how you guys, solve these problems in a different way as well. So now what we have, look how beautiful that is. So essentially what we have is, yeah, just 5 top cities, with average price, seeing how far we've come from having a huge data set that has, maybe a little bit of, uh, uh, you know, not clean data and not easy to read data. We shaved it down. We said, okay, let's only find the cities, let's only find the prices. And then after that, we found the top 5. So it's interesting to, to see the progressions that happen, versus seeing how it happens through the code. So I would say we are done with that. Moving on to ggplot. So I'm just going to plop down the entire code chunk right here for you. So ggplot, is good for many different visualizations, but in this particular ggplot function, we are going to be using geom bar, which essentially just specifies that it is going to be a bar plot. So some things you do have to do with ggplot is specify the data frame that you're using. You're using this, the small and beautiful tiny data frame that we just created with all of that code. And then here's the aesthetic argument, which essentially you're assigning the X and Y variable. What I'm doing with this reorder function right here, when assigning the X variable, is saying I would like you, to obviously pull from the, use city as the X axis, but also, oh, wait. So reorder city. Oh, so you're essentially reordering all of the cities. You're essentially arranging all of the cities to go um, in ascending order from right to left, meaning we expect the city with the highest average price to be on the left side of the column, and then we expect the city with the lowest average price to be on the right side of the plot. Sorry, I meant plot, not column. I'm sorry for them making sense. It's pretty late. So yeah, that's what we're doing. We're, defining X and Y. We're using plus instead of a pipeline operator because it's not like we're doing, multiple functions that need to happen in a certain order. We're essentially doing all of these things at once, within this one ggplot function. Um, I don't know of many times where it needs to happen sequentially like this. More so, you're just saying you're adding on very, very specific elements that you want to add to your plot, which I actually think is the reason why ggplot is so powerful is because it allows you to do many, many different specifications. I mean, this is just a very, very, very small set of specifications and customizations you can make to your plot. For example, labs, labels. So here's the title of the graph. Here's the x-axis. Here's the y-axis. You can even change some of the themes. So I want the labels on the x-axis to actually be at a 45-degree angle instead of like horizontal or vertical. And then this has to do with spacing or size or font. You can really, really change everything about, your plots. And I think that's a very, very exciting prospect. So let's see. So one mistake I'm noticing is that the y-axis and the numbers here are being represented to like magnitude, or I don't know why it's like presenting it the number like that way, but I believe this is like 25 million, and then this is like, hold on, yeah, so that's 25 million. Um, I'll have to figure out a way to fix these labels, and I probably want more labels, so these are all things that you can do within this ggplot function, and maybe that'll be the next video, is how to make your plot look pretty. Because right now this is not the prettiest one. But yeah, so what we did was, we imported a data set, we viewed it, we cleaned it, we made specifications and edits to it that were uh, relevant to our objective, which was, hey, I would like a graph of the 5 cities with the highest average housing price, and I'd like them ordered. So I hope that that was helpful, and I really hope that for some reason the Zoom recording works finally. Goodbye.